Hello everyone, it is Dr. Hakan Satıroglu. This screen showing us just I would like to illustrate and today on a neural network, and I would like to pack how you need to evaluate the best model is going to working for you. This screen is showing the like kind of interactive screen, and codes are here, Python codes. Little bit zooming. MLP classifier is a neural network classifier in Python codes, and it is using some other parameters inside. So that parameters are applied here, and when we move, just you can see the task is working. So I would like to go one by one, each of them. Need to repeat again training and test section here, but according to this mentality, this machine learning algorithm, as you can see, 20% is test size is used applied in the Penguin data, while checking the Penguin species, different species exist. 3 different species are existing in Penguin data, and we are estimating which penguin is going to be according to 2 algorithm, different mathematical models. This is our aim. This is our aim, and so when we see that architecture, this interactive architecture screen, you can see the first we have hidden layers, and as I change it, you can see 1 layer here and second layer. So as you can add as many as you want here, but in this interactive screen, I included only 3 of them, 3 layers. So as soon as you change it, and you can see the network is keep changing. So this is the middle layers are called hidden because we don't directly see them in the original data or the final answer. That's why we call sometimes this is a black box, and some of the critics exist here, and the hallucination by used or generated by AI is mainly coming from this, because it's trying to answer your prompt by using the neural network, and sometimes neural network making some wrong or taking you somewhere you don't want to wish to go. So you can think of the hidden layers as extra thinking steps. So each layer is adding thinking steps, and each layer has got 1, 2, 3, 4, 5, 6, 7, 8 different points. Okay, so these nodes are giving some extra elements and extra thinking time for the machine learning. As you can see, it is as much as you add, you can keep your computer really working hard, but you can get less accuracy or more accuracy on the parameter screen you are going to see here in a second after running that data machine learning algorithm. So neurons per layer is kind of like you are adding neurons or reducing number. Okay, so you can think of neurons like tiny decision helpers, and each neuron is gonna give machine learning to think and decide 1 extra point about your trained data, and later on you are going to test your data according that because after a certain training period, machine learning is creating solid model and testing that model with your test data. So more neurons means the network has more little work, and to help process the information, if you add more, and it's going to improve add more nodes. So as much as you add, this kind of neurons are thinking, or machine learning are thinking about your estimation or prediction. Now about that activation code, which is really important actually, and it is giving us sigmoid function. You remember from the logistic algorithm, the logistic function in with 2 or 3. It is giving us 1 or yes or no answer. So it is kind of like if you select sigmoid function, you can select in neural network, it can give you yes or no. If you go with ReLU, which is mainly used by many application in practice, this is like giving you each neuron a rule, because we are setting here rule for each neuron and how they are going to think, and each neuron a rule whether it should strongly or weakly or not much give attention, in a way yes or no. So ReLU is keeping a bit non-linearity. It means like this is essential for the real world patterns, because in many cases we see linearity is not valid, and so this is common activation function ReLU, and I suggest you to go with ReLU always instead only yes or no function or tangent function. So yes, and learning rate. This is the third one or fourth one. Learning rate determines the size of gradient descent, this step during the optimization. If it is too high, training may become unstable. If it is too less, you can jump some of the training sections. So yeah, literally it is in coding. You are going to put 0.1 or 0.01 or this one. So if it is too low, learning can become very slow. If it is too high, which is 0.10, the result could be really unstable. I'm going to keep that one is 0.01 in the middle. This is like you are going to check whether which accuracy is, you need to check actually in real world, in practice, which one is better result, and you need to go for it. But at the moment, we don't have anything in real world case at the moment, but we are just learning about it. So the last one is EPO, and it is set as 100 here. If we train for 100 EPO, it means the network gets 100 full chances to go through the data and improve its weight. Like let's say I'm asking you to revise one chapter from one textbook. Then next day I'm asking you to revise 3 chapters. It means like you are revising the many sections from the data. So it means like EPO is making this one. Each EPO repeats the forward and forward pass from here, and loss calculation. We are going to have a look at that one in a second. Loss calculation. And parameter updates across the data set in a way. And too few EPO means the model has not learned enough. Too many EPO, it may start memorizing some outliers, and it is going to include too much in the data set. So literally, you are going to check which one is working better. Then you are going to work for it. So, but I must say, from the Penguin data, they are not making too much difference. So it is difficult to illustrate here. But yeah, in real world data, you can do that one. So after setting these in the interactive way I'm using, and I embedded data inside this application as well, and I'm going to train the network. This starts a learning process. And you are going to see the training curves and learning curves here in a second when I press that one. So the neural network begins adjusting its weight using the data. As you can see, it is running and it is making that. I just want to go with a little bit like about the, maybe I should try maybe this one, reset weight. As you can see, learning rate is causing a little bit like Humpty Dumpty results. Okay, jumps. If you add, because it is unnecessary, because 97%, if you go with 0.01, it is 97%. So then you don't need to go much smaller number. So you can keep it like optimal way. Okay. So so here is in the metric size, we can see train accuracy, loss, EPO, and parameters. So actually, it is train accuracy is about this tell how many training examples the model predicted correctly, and the training accuracy is a proportion of correct prediction. So, but remember, good training accuracy doesn't always mean good real-world performance, because we have different models, and some models might get good results. But according to our scenario, I would like to go later on about that one. What you are checking in what is your aim in the machine learning is one of the prediction of selecting the models, predictor of the selected models. And now let's go to let me explain the loss, because this is the hardest part for me. Loss is the model's mistake score. For classification, the network often uses a loss such as a cross entropy, and this penalizes the model more when it gives low probability to the correct class, especially when it is confidently wrong. So simply, I can say loss is like accuracy. While accuracy is telling us whether the answers were right or wrong, loss tell us how wrong the prediction was. So therefore, both of them is important. So accuracy is in a green line, and loss are in here is the red lines. So from our training, the optimal way is kind of 97% according to this model parameter. If we jump another neural network 2, 3, let's say, reset and run, again 97%. So if we just you are going to work and you are going to see how stable the model is working. So 97% for the sigmoid as well. So changing these doesn't make too much difference because of my data probably, but in main case in real world you need to check them anyway. So so these are the Python codes are given here as well. This is the data is tested with 20% testing, 80% training section, and so this is in a short way, I can say this screen is the control panel for neural network. And it is showing and illustrating us how the model working and accuracy is created. If I need to go to forward pass, the Penguin measures, and you will see some of the output probabilities are here. So it is same with the prediction. Actually, this is repetition, same things. But this one is only showing, the neural network as an illustration here. So if we catch in our data, Flipper length is 200 millimeter penguin, with Kuhlmann length is 35 millimeter, and Kuhlmann depth is 920 millimeters, and body mass is 3 kilo. Then the probability of outcome is Adelaide is 37% is the probability of that penguins is going to be specific of this Adelaide. If let's say, because we know Gentoo has got a Flipper length is really long, so as you can see that Gentoo is probability is increasing. If it is low, reduce, it's becoming so less probability. So kind of you have this measurement and you are predicting the species of the penguin from outside. Okay, let's put that one a bit different. Adelaide here. Then as you can see, it's changed now. So this is machine learning, and as you can see, as soon as I change, and you can see the neurons are becoming darker. Somehow it is working inside, but there is no logical explanation how it is working, because there is no that's why we call this is a black box. So this is simply the same thing. So when you have after training, you have some kind of evidence like Adelaide is 37%, body mass is increasing, and let's make them all of them 100%. Okay, and Adelaide is the one of the top 46%. So if we remove them down, then as you can see, it is Flipper length is again Adelaide. So it seems Flipper length is mainly in favor of the Adeli. Then if you check that one, you can see Gento is the top, 47%. So this is the data analysis, and this is the prediction side. You know, all this learning, all this accuracy, precision, recall analysis, and different type of model, decision tree, random forest, KNN, is about this prediction. We are checking and we are using these algorithms by changing different, by changing these parameters and to estimate best possible outcome. Okay, I think this neural network is done, but I would like to finish these lectures, machine learning lectures today. Kind of wrap up here is the one-line memory on map. Decision tree asks sequential if then question, yes or no answers, follow up. Then you can think this is a flow chart, simple way to say. Random forest average many trees or decision trees. Many decision trees are becoming together and reduce. This is random forest reduce the variance, and many trees work together. This is the function, how it's working. KNN, K neighbor, nearest neighbor, looks at the nearest level points, copy nearby crowd. It means like herding, you can think. But yeah, this is like nearest point is classified. And SVM, choose the boundary, like we say, road, motorway, widest margin, draw the best road between groups. So each of the algorithms are here given, and I just make some of the parameters I used. I mean, machine learning is using. Okay, please don't forget them. Okay, you don't need to memorize any of them, but you need to think these parameters, how, if they change, how the model is stable. Stability is important. So first, keep the train and test splitting. You need to split train and test section in the data. If you don't do, your outcome, your accuracy is going to come as 100%. And I made that error earlier, one of the example. So train, if you train your model, and if you test your model on the training data, same data, then this accuracy is going to be 100%. So yeah, this is important. Then compare the model is important. So after training, compare the model with the test set. Choose the metric that matches the real goal. Read the class report and not just one overall number. Finally, prefer the model that is both strong and sensible. So that one is technical, and it is showing. It is going to show you. It's going to show your technical knowledge and practical how you are going to make practical decisions. It's really important. So, so which model is has got the model highest accuracy? Which model got the highest accuracy means best model? This is a bit questionable because we are not looking. We shouldn't look at only accuracy. We should look at trustworthy of the prediction task, because as an analyst, you should test model and you should test models or models. Okay, maybe I should say models against 5 check: unseen data performance, per class fairness, stability across split, and complexity, appropriate complexity, or because you have some kind of puzzle and your puzzle not be answered by choosing one of the model because it is accurate, but it is not explaining you good result. Like neural network doesn't give any explanation, but you may need to have explanation. So you may need to go with that way. And these 5 checks are here. And high performance on unseen data. Use the data set, not the training data set. And the model is score 100% on training data, may simply be memorizing all of them. And it means, can it answer new questions, not only like homework questions? So new questions, new data, new species are come, new size, new penguins with different sizes come. How effectively your model is responding. So this is important. And we tested that one with Monil, just increasing the size of the Kuhlmann land or depth or Philippine land. So the good result for every class, you need to check every class, different models, different species, check the recall. It means recall, remember from the confusion matrix. And in the week we go through an F1 for each class. Not only overall accuracy is not going to helpful. So recall and F1 is one of the important element. I think you should work on it. You should definitely take consideration on your decision. A model is weak if it predicts readily well but misses the chin strap and Gentoo. So this is therefore maybe you should change your parameters and you may need to go more stable model. So similar results across the different splits are important. Change the random state or repeat the train test split. It performs maybe different, then the model is unstable. So as you see, neural network, they were about 97 to 98, all of them were okay. So so it means is the result reliable, or did we get just the result because of the luck? So this is the stability. So when you are checking decision and you need to make 5 checks as a manager or as an analyst, you need to go through all this. I think I didn't go through this underfitting and overfitting elements. If you keep simple your model, it's going to miss the pattern, so it is going to be underfit. Okay. If it is too complex, if you keep your model too complex, it's going to be overfitting, memorizes the noises, memorizing unnecessary things. So it is not helpful. So so the question is the model learning the pattern, not the accidents. Okay. So yeah, some of the outliers could be accident, so it's not going to happen at all. So yeah, you shouldn't make your model tired, I hope. So I made this next slide for kind of which metrics should an analyst use: accuracy, macro, F1, recalls. These are given in the confusion matrix in the week 3 and balanced accuracy. So this is kind of like you are going to evaluate that one. And loss is about, this is the neural network element. So it is not in, neural network doesn't give us that recalls. In many cases, you can check the loss against accuracy and you can follow up your outcome by using loss result. So the scenario and what you are analyzing is one of the important one is that one. I think. Let's say I gave 4 scenarios here. So in terms of our Penguin data, species counts are balanced and all errors are equally important. If you have this aim, use the accuracy as a metric as a first. So when you are evaluating your elements, your models, you need to check. You are going to evaluate things according to your aim. If your aim is in the scenario 2, one species is often missed and you care about catching them, focusing on the recall. Okay, so this is the section. If you want the species on the third scenario, if you want each species to matter equally in the score, use the F1. Remember the balance accuracy, F1 score, and a neural network loss, but test F1 get first. So this is like stop trusting loss alone. Choose the better test metrics according to your elements. Okay, so because this coming from the neural network is a bit black box, and we don't know how it is deciding how that neurons are following each other. We don't know. At least I can say it is not same clear mentality as decision tree. Okay. Overall, you need to train your model with different models. You need to train your data. You need to train your models. I mean, your models is going to be different models, and decision tree, random forest, k-nearest neighbor, and SVM and neural network, and test them. Check the result, accuracy, F1 and recalls, and inspect classes report with recall per class by using confusion matrix. Then check stability. Try another split. Change. It means try random because 20%, 30%, maybe 40% learning, training, then 60% testing. See if the result stays similar. And choose and justify pick the model that is most reliable for the actual goal. Your actual goal, I gave you here as an example. If your goal is you want each species matter equally, then F1 should be important. So this is your goal. Okay, these are your goals, your mentality, how you are going to evaluate your outcome is coming from here. So I made one of the examples. This is the on the base of this hypothetical table. I made that one really quickly. I choose a random forest because accuracy is 97%, but the neural network is higher than that one. But I can see that recall is here 98 and 97. So I don't have any aim. I didn't have any aim here or mentality. So because it performed very strong on unseen data set. Okay, then had a high macro work well for each class, stayed stable. And it also avoided the extra complexity of neural network. So it means I can explain more easily for this one. So maybe I should teach you that one is the important point is a neural network can win for everything. And still not the best managerial choice because due to the difficult explanation of neural network regarding interpretability and reliability. And sometimes it matters. Sometimes it matters more than a tiny score advantage by using accuracy or macro level. So explanation, because we may need to go with explanation. So complex models like a black box, simple models like a clear set of steps, and we can start to explain that one to your boss or your manager, or you can see the real reason behind it. Okay, I think I'm done all my machine learning, and I would like to jump to forecasting section on my next video and next tutorial. Thank you very much for listening.